welcome you to the Production Logistics webinar hosted by me, Josh Buchan, your local mechatronics specialist here at SMC. I'm excited to get to share some great information with you today, as well as sharing some brilliant minds in Curtis Beaumont and Mike Amendola from Rockwell Automation. This is a live webinar, so your mics will be muted, cameras off, and we will be answering questions live, so keep them coming. Let's have some fun. Production logistics has a direct and measurable impact on manufacturing performance, yet it is often treated as a background function rather than a core performance driver. When materials fail to arrive on time, production stops, immediately reducing availability and lowering OEE. When lines wait or slow down, throughput is constrained. And when skilled operators spend time moving material instead of running equipment, labor costs increase without adding value. In many facilities, material movement remains reactive, dependent on manual calls, forklift availability, or fixed tugger routes. This variability introduces instability into production, and instability is the enemy of performance. Today, production logistics is evolving beyond simple material transport. Autonomous mobile robots from OTTO Motors are transforming how materials move across facilities, dynamically delivering the right material to the right place at the right time. When combined with independent cart technology and unified robotic control from Rockwell Automation, manufacturers can extend this intelligence directly into production processes, synchronizing material flow, machine operation, and robotic handling within a unified control environment. Together, these technologies create a connected production logistics solution. OTTO AMRs orchestrate facility-wide material movement, while independent cart technology enables flexible, high-speed product flow within manufacturing cells, and unified robotic control seamlessly integrates robotics into a common automation architecture. The result is stable production, optimized labor utilization, and logistics that actively drives manufacturing performance rather than reacting to it. Because the reality is simple: when material flow is optimized, production performance flows. A major aspect to production logistics is autonomous material movement. This is where autonomous mobile robots change the model. Instead of reactive forklift calls or fixed routes, AMRs deliver material predictability and on time. They dynamically adapt to changing production demands and operate without fixed infrastructure. That means material arrives exactly when it's needed, not too early, not too late. The result is stable material flow, and when the flow becomes stable, performance improves, availability increases, throughput improves, labor is redeployed to higher value work. Production logistics shifts from being a constraint to becoming a lever for operational performance. Today, we'll explore how OTTO AMRs make that shift possible. To go deeper into how this works in real-life manufacturing environments, here is Curtis Beaumont, who will walk us through OTTO AMRs in more detail and show how they're delivering measurable results on the factory floor. Take it away, Curtis.
Thanks, Josh. Yeah, so my name's Curtis Beaumont. I'm a mechatronics solution consultant from Rockwell Automation. Been with the company about 25 years and have the pleasure of working with Josh and Mike in the mechatronics space in your area. So glad to be here, really excited to talk about OTTO. OTTO was an acquisition by Rockwell about 3 years ago, so 2023. It's been around since about 2015, so a little over 10 years. And that's really when the industrial automation space saw a proliferation of AMR companies, right? So we're going to talk about some of the challenges, some of the benefits, and why you'd want to use OTTO as well as Rockwell Automation. So next. So we've been facing similar challenges for a long, long time. If anyone's been in the industrial automation space since the pandemic, you've seen these same things pop up, and they've been exacerbated by supply chain issues and labor participation rates, et cetera. But it's really hard to find people. It's hard to retain people. So if you can find someone and train them and spend that time and that energy and that money on training them, you don't know if they're going to be sticking around 2 years or if they're going to be sticking around 2 weeks, right? Not only that, but the costs to hire people are continually rising, right? So if it's training costs that are going up or just the entrance cost for acquiring a new hire, they've been going up substantially for especially the last 5-6 years, right? And in this space where we're doing material handling, it's getting to be increasingly unsafe, right? The demands for warehouse transportation and material handling are going up with just the increased need, and what that generally means is that there's more drivers on forklifts and there's more forklift accidents. So you can see in that bullet that 78 work-related deaths and over 7,000 non-fatal injuries were involving days away from work have happened since just in 2020. All right, so that's just another reason why we want to maybe automate that material flow. Next. So this is the next disruption, right? So a lot of people are familiar with AGVs, autonomously or automatically guided vehicle. The difference between an AGV and an AMR is the fact that, as you can see in this video, there's no stripe on the floor that it's following. There's no magnetic rods drilled into the cement floor that it's following. It doesn't have a path that's strict, right? You can see as this warehouse operator walks across the path, it slows down, it does a little shimmy step. It's trying to decide where it goes. It first ducks to its right because the operator appears to the left, but as the operator goes across, it's slowing down and then veering itself off to its left to get around that operator. You notice that it also is sliding by the forklift operator too. If this was an AGV, there would be no variation from the line that it's on. It would simply have to slow down. There's no way that it'd probably have to wait behind that forklift. It would have to wait behind the production person as well. So the benefit of this is that it can mimic the manual material handling, but it provides that automation that we've been looking for. It's very flexible. So next. So why OTTO? Like I said earlier, right in the mid 2010s, we saw a huge proliferation of AMR companies come on the scene, right? You saw Boston Dynamics with their Spot robots, the automated dogs. We're seeing Tesla with their humanoid robots, and those aren't the only ones that are doing humanoid and animaloid, if that's a word, robotics. We're seeing a huge build out of AMRs like you would see with the OTTO fleet. So why would you want to choose OTTO? You've got about 150 different AMR companies to choose from. Well, one, safety, right? OTTO employs the best and strongest and most robust field set of safety devices and safety features of any AMR company out there. Two, we have a very broad spectrum of hardware portfolio that we'll show in a later slide. And three, hopefully this is a benefit to you, they're backed by Rockwell Automation. Knowing that Rockwell bought OTTO about 3 years ago, and we are integrating that into our hardware and software portfolio should give people confidence that it's going to be around for the long haul. If you were to choose another AMR fleet that isn't backed by a major player in the automation industry, who knows if you're going to be able to get parts, get service 5, 10, 15 years down the line. That's what Rockwell's known for. We're known for sticking around for the long haul. So next. Yeah. Another thing is the buildup, right? OTTO is becoming one of the largest indoor logistics operators in the world, right? You can see on the slide, 5 million plus mission critical operations. And this, as you can read the bottom of the slide, is as of 2024. As we're building out, we're ramping up exponentially. We're talking 400,000 deliveries completed every month. That's probably closer to 600,000 now. And then 15 years of industry leading robotics experience, right? So even though OTTO was incorporated in 2015, it started well before that with some skunkworks projects as well. So next. And what we try to do is bring the entire package, right? You can see the hardware portfolio on the left. There's other AMR companies out there that have similar looking hardware, similar feel, but they don't have the autonomous operating system, the fleet management software, the fleet analysis software. And what's not on this slide, which will be launched here in April, May timeframe, is a middleware software that's built on Plex, so built on Rockwell software. It's built to configure, not to rewrite, right? So our goal is to make integration as simple as possible and to blow past the competition in that. And then the third major leg of the stool is the services and support, right? So not only do we have expert services on the phone We have remote services from OTTO, but also our lifecycle services, are basically our field service engineering team nationwide and globally is being stood up to support automotors as well. So you get the same look and feel, services and support as you would with any other Rockwell Automation product. Next. This is another thing too. We are trusted by industry leaders. Obviously, Rockwell Automation is a trusted brand name, right? We have North American dominance when it comes to our PLCs, and we have a great install base of our general motion control, our VFDs, et cetera, et cetera. And our customers, like the automotive OEMs and the tier ones, they trust us. The consumer product companies trust us. If you were to bring a Rockwell solution to any of these companies and many more beyond this page, people are going to open that door for you, right? They're not going to say, "Who is this? Why would we want to bring you in?" They have a level of trust. We have a name that we carry around with us too. So we want to make sure that OTTO is not a failure. We want to go to the absolute ends of the world, ends of the earth, to make sure that your OTTO integration is successful. And we've done this for over 120 years, and we plan to do it well into the future. So next. So some of the use cases that we want to get into next, Josh. Yeah, you can see there that it's a pretty complex machine. I just want to go over some of the basic use cases. Obviously, bringing materials to and from people, as you can see on the left-hand side, that's an example of our smallest little AMR. It's OTTO 100. We offer a range of solutions that we partner with third parties to bring to the table. We can bring a turnkey solution to you, including the AMR, carts, conveyors, lifts, etc. So in this case, on the left-hand side, we have a third-party cart that we can bundle into a solution, and that OTTO 100 comes under there, lifts it up, carries it over to another place, and maybe delivers some material to people. I call it a target cart because it's painted red. So that cart can be a flatbed like you see there, but it can also be an enclosed cart where you're just throwing loose articles in. The middle one would be something like a OTTO 600, 1200, or 1500. In this case, it has a roller conveyor top module that's been affixed to it. Once again, that's a third-party device that we partner with, and like I said, we can bring that as a turnkey solution to you and your customers. So that would just be bringing materials to and from automation equipment. And then on the left-hand side, what we see is an example of like a lifter application. So very similar to a fork truck, where we're picking and placing on pickup and delivery stands. So if you are using a standard pallet dimension, our lifter is a very common solution for that. All right, next. Yeah, getting back to this here, this is a good example of this. We know that ASRS's, automatic storage and retrieval systems are very large, and they're very difficult to move. Once they've been installed in your plant, you generally have to move ancillary equipment around that. So in the case of an ASRS like this, if you have different needs, different layouts of your plant, whether it's a distribution center or if it's a manufacturing warehouse, the benefit of OTTO AMR is that you can leave your ASRS in one location, maybe make minor changes to it, conveyor heights, etc. But you can adapt the location of the ASRS to the location of different equipment. In this case, it might be a DPAL robot, or it might be a palletizing robot. Who knows? But the OTTO can be used to bridge the ASRS to that other material movement device, right? So, and it can be very flexibly deployed once it's installed as well. So next. Another example might be a palletizer to a stretch wrapper, or a stretch wrapper out to a delivery system, a docking system. How often is it that you get a device such as a palletizer, and you get another device, a machine like a stretch wrapper, but the throughputs aren't matched, right? You're buying a stretch wrapper from one company and a palletizer from another company, and the throughputs on either don't match. But let's say you have a combination of multiple palletizers and multiple stretch wrappers. You don't have to make those one-to-one. You don't have to waste money and space by saying we need exactly one palletizer to one stretch wrapper, right? You can use the OTTOs as an interface to deliver from any palletizer to any stretch wrapper, and then use that same OTTO to pull off the pallets and deliver it to a dock system, that sort of thing. So it allows you the flexibility and the configurability to scale in the future. Next. So what is our solution to this? Next. As you can see in these videos, we have unparalleled productivity and safety, right? You'll see that all of our robots include a 360-degree LED strip, and it also emits sounds. But that strip is very intuitive to read. So if you're looking at the robot and trying to decide what it's doing, what's it going to do, it has blinkers, essentially it has brake lights, it has like a flashing LED that will tell you to, hey, listen up, I'm trying to tell you something, you're in my way and I don't have enough room to move around you, right? We have very efficient fleet orchestration and integration. You can see in the upper right a whole bunch of OTTO 100s moving carts around different locations, right? That is what we pride ourselves on, is making a very large scalable fleet very simple to integrate. The bottom left just shows the accessibility of our AMRs. We give you access to most of the machinery inside the AMR, whether it's the battery or it's the boards or what have you. So if something were to fail in the field, most of the hardware inside the AMR is serviceable. And then the last but not least on the bottom right is we give you actionable insights. That's something that Rockwell prides itself on, is giving customers the ability to look into the production and make changes dynamically, manually, what have you, to optimize your throughput, right? Also allowing you to understand where your bottlenecks are, what's your return on investment, etc. Next. Going back to the safety aspect, we can't get production without being safe, right? So you can see across all of these, we were on the RIA standards board, as you can see on the second bullet on the right hand side for the robotics initiative. It was co-authored by OTTO to make sure that we are basically abiding by any sort of North American worldwide standards for robotic safety, right? We are designed to work with people, right? We have safety rated LiDARs, 3D camera sensors, etc., and an onboard AI that enable the emergency stopping. We characterize our machines, our AMRs, so that we are looking forward and making sure that if anything crosses our path, we have basically a safe stopping distance so that we're not going to collide with someone, we're not going to run over their foot, we're not going to damage product, we're not going to spill product too, right? So that's super important to us, and it's unmatched in the industry. Okay, next. Yeah, productivity is unmatched as well, right? So this is an example of an OTTO 100 all the way up to the lifter, right? So we have the smartest autonomous driving in dynamic environments. Not only that, but we have the ability to scale out more than any other AMR company in the world, right? So some AMR companies are very much limited to 5, maybe 10 robots in a certain work zone. We can scale out well past 100, and we have several instances where we're running over 100 AMRs in one exact zone where they're all interacting with each other, right? We also have a robust localization algorithm. So we know where we are at all times and we don't get lost, right? We can remap zones too. So if forklift operators are dropping boxes in a zone and we have to navigate around them, as each AMR is mapping around these zones, around these certain areas, we're developing basically a new field set for that zone, and we're redeploying that on the fly. So if one day we start seeing things stack up, we can actually notify the production facility to say, hey, you know what? This has been stacked up in an area that we would generally want to route our AMRs through, and it'll also quantify the productivity loss based on that as well. So, yeah, and it's optimizing paths and routes quickly, right? So if we see these things stacking up in a certain alleyway or a certain aisleway or whatever, we can reroute to a different aisleway. Let's say we've had to stop and reroute multiple times. We will stop using that until something is actually done about that, right? So yeah, and we avoid static and moving obstacles very efficiently. You can see where, every AMR is going to do this little safety dance when it hits like a moving obstacle. We have algorithms that are specifically built for our AMRs to avoid them quickly, so that we're not languishing there waiting for something to move. All right, next. This is one of the cool things. This is kind of adapted from high-end car technology. It's the adaptive headlights, right? So not that we have to illuminate the path, but we are looking through the corners, right? If you've ever taken like a speed driving or a racing course, you're instructed to look through the corners. You're not looking right in front of you. You're looking past for where you're going to be going. That's what our AMRs do as well. And that's essentially so that we don't have to like stutter step ourselves around the corners. It's a very smooth transition. And so all that leads to increased productivity, right? Faster task completion times. Next. And this is all done through our fleet manager software, right? Orchestrating our fleet. You can see this is a live video of what you would see on here. So not only is it easier than anyone in the competition to stand up and deploy, but it's also easier to integrate into our production environment, right? Rockwell being a PLC company, largely we are making those hooks to our PLCs into our ERP and MES systems, right? So we are taking what would take weeks, months of deployment time, and we are rapidly shrinking that down so that you can redeploy, rescale, expand your fleets, and adjust to new work experiences and new discoveries. Right. Next. Yeah. So this is just an example of real world PLC integration. Right. So what we're doing is through the Fleet Manager and through different protocols that are actually fairly agnostic, where it's not just a SIP, right? It's not just Ethernet IP, but we're open to like MQTT and OPC UA, right? We're allowing our integrators and our partners to integrate to anything out there in the real world. On top of that, like I said, we're going to be launching what is now known as Rockwell Integrated Production Logistics, or RIPPLE. It will most likely be changed in the future. That name will be changed to something else by April, May timeframe. And what that is it's a middleware software that sits on top of our fleet manager. And it's designed to be configurable, not programmable. So essentially just very simple hooks into your MES, into your ERP system, that would go between that and Fleet Manager, and allow us to make very simple logical determinations of where each AMR needs to go, timing things appropriately so that there's no gaps in production time, right? So be looking for that later this spring into the summer, right? Next. Yeah. Our goal here is to maximize uptime, whether it's with our middleware software tying into the MES or it's down in our hardware. In this case, this slide is really talking about what we're doing on the hardware layer. Our AMRs are designed to be opportunistically charged, and what that means is that when it sees a gap in the deployment of going from one point to another to pick up a load or drop off a load, if it sees a gap of more than, let's say, 5 to 7 minutes, it's going to find an open charger and charge itself up if it's outside of the 10% to 80% battery level, charge level. So what that means is that if, let's say, you've got an AMR that it has a gap in time, and then there's an auto charger where there's an AMR sitting on there that's at 60%, right? What it will do is, through the Fleet Manager software, is it will tell the one that's at 60% to vacate, and the one that's at 30% will actually come onto the charger and opportunistically charge, right? So if it's at 80% and it's not in its overnight, let's say, downtime window, that AMR will likely come off and just allow other AMRs to come in and charge opportunistically as well. So the goal of this is to make sure that we don't have any gaps in downtime, so that a shrink wrapper or whatever is not waiting for an AMR that's just sitting on a charger, not doing anything, right? That's one thing. But we also want to manage and extend our battery life, right? If you're an iPhone user, especially, that's all I use just because it's a company phone, is they've put algorithms into the phone to make sure that we are staying between that 10 and 80% charge barrier to lengthen the battery life as much as we can, right? So yeah, so that's one of our algorithms that we've built on, and yeah, it just extends the life of the battery, extends the life of the AMR. All right, next. Yeah, and another thing too, like I said, Rockwell's all about actionable insights, right? We want to make smart decisions, and that is done by basically opening up the software to making actionable data available to you. So what you'll see with the fleet metric software is essentially, how many tasks has the AMR done? How much standing around time did you have? Did you have any canceled missions? Did you have any failed missions? Right? And then you can drill in to understand what's happened. Why did this get canceled? Why did it fail? Right? Did we have any hardware failures? Because it does happen. You can also look at the AMR specifically to see if there's any AMRs in there that are outliers when it comes to distance traveled. That might mean that we may want to service that one earlier, right? So all this stuff also ties into our QMMS system as well. So yeah, we have very sophisticated analysis tools that we make available to our customers. Next. All right, so let's talk a little bit more about the hardware portfolio. Next. Yeah. So you can see in the slide deck that we are featuring basically the toppers, the modules that go on top of the AMRs, right? I'll start on the left, right? Those are two either OTTO 600, 1200, or 1500 AMRs. They all look kind of the same to me, so it's hard to distinguish which is which. On the left-hand side, we've got a lift. This is a third-party device. We partner with a couple different companies depending on location in North America. We like to actually make sure that they're close to the end user customer, depending on cost, etc. But they make the lifts. They also make the P&D stands, the pickup and delivery stands, right? So depending on what your use case is, we can partner with, like I said, a whole bunch of different integration arms that'll do that. Same thing with conveyors. We have inline and side transfer conveyors. They're available for most of our devices, right? And some of those conveyors are actually, they might be power takeoff conveyors where instead of delivering power to the rollers to roll that pallet off the conveyor, we put a little arm out that has a wheel that's geared to all those rollers, and we use the power that's coming off the conveyor that it's going to in order to drive those conveyor wheels, right? And so that doesn't consume battery power from the AMR. And then the third and final thing on the right-hand side, our OTTO 100 comes with an integrated lift. So every OTTO 100 that you buy actually has a lift. We have different clips and different attachment mechanisms so that when that lift comes up underneath that target cart, it'll clip in so it doesn't slide off when we're accelerating and decelerating, going around corners. But that lift, like I said, in the OTTO 100 comes standard, right? So yeah, these are all done, like I said, by third-party integration arms, but we can make it a turnkey solution. So if you come to SMC, to Rockwell, to OTTO, and say, I want X number of P&D stands and I want these, we'll make sure that we simulate and characterize your systems so that we're not under or over selling you on any of these things. And we will actually bring this as a turnkey solution to your warehouse or your distribution center. Next. So this is the AMR portfolio as it stands right now. So on the left-hand side, we have that cute little OTTO 100. Little is being doing some heavy lifting here, though. 330-pound weight capacity on that, right? So that's not a small device. All the way up to, in this case, the OTTO 1500, where our heaviest payload capacity is actually 1,900 kilograms, not 15, or 4,200 pounds. With a topper module, we generally derate this back to 3,500 pounds on average. So if you're looking at, what a reasonable payload would be, unless you were palletizing and depalletizing, and all you had to do is carry around the pallet. Generally, our max payload is going to be in that 3,500 pound payload range. And then last but not least is the OTTO lifter on the right-hand side. So it's an autonomous forklift. It's designed to help move pallets up to 1,200 kilograms. Right, you see on the back side, it actually has the manual yoke, if you will. That allows us to move above an automated level of about 40 inches. So in autonomous mode, we can pick up and lift up to those forks up to about 40 inches. That's just based on robotic standards, right? So if you have an AMR company coming to you saying that we can autonomously lift above 40 inches, you may want to dig into the details and find out how they're doing that. See if they're actually safety rated, what certifications they're using in the field to actually get to that. So next. All right, so we talked a little bit about the different robots here. This is that 100. Like I said, it talked about the 360-degree LED integrators or indications, the integrated lift, the e-stop in the front, two forward-facing 3D cameras, and safety-rated LiDAR. That's key. But one big thing too is it's a steel frame, right? We know that we're not going to displace everyone in the factory or in the warehouse. You're probably going to have fork trucks running around, and guess what? That steel frame is going to be pretty handy when who knows who on the second shift runs into this thing with a fork, right? It's a much more robust AMR compared to some competition. So next slide. Yeah, the OTTO 600 and 1200 are based on the same frame with different payload capabilities, right? So with the 600, you get a lighter payload capability, but you might get a little bit more runtime or speed. With the 1200, it's the opposite. But essentially the same safety features, same steel frame. We have that rapid access drawers for service, right? Two forward-facing 3D cameras and the LED indication 360 degrees, right? So with all of these AMRs, we have automatic chargers too. So you slide onto the pad and slide off the pad, and the charger takes over. Okay, yeah. Next, and then the 1500, the big guy, right? In this case, we've got two e-stops, one on the front, one on the side, right? But almost all the rest of it is the same, right? We have quick access panels on this one to get into the middle of it instead of the trays, right? We have 4 3D cameras, right? 2 in the front, 2 in the back, right? And then we have corner LiDAR sensors too, right? So, and then the next final slide, I think, is on the lifters, or the lifter. Yeah, and the lifter is great. We have a couple key features on the lifter that make it better than others. We have fork sensors in the front. So if you're doing a lot of stretch wrap and you want to pierce the stretch wrap, we actually have that detection. So there's a sensor in the front. It's actually a mechanical sensor that gets placed. So you can run into it, and the lift knows that it's not running into something hard, right? So once it pierces the stretch wrap, it dives in more quickly, right? Yeah. Once again, it has the manual yoke. So if you want to place pallets above that 40-inch capacity in auto mode, you can switch over to manual mode and bring it up to, I think it's about 100 inches. So yeah, it's quite a range. This is obviously it's not a high lift fork truck, right? So it's designed basically for bringing pallets around a warehouse off of medium height, stands, that sort of thing. So, but yeah, you can see they've got payload sensors up on the top of the boom, and then we have 3D cameras around the back and the front, and then payload sensors too to make sure that we're actually driven into the payload on the pallet. Next. So the third and final stool or leg of the stool that we bring to this is the services arm, right? So I talked about OTTO having their own internal services organization. Next slide. That is still true. As we're integrating OTTO into Rockwell, we still have direct support by OTTO. We still have live technical support and on-demand tools and training through OTTO. So that's in Kitchener, Ontario, which is in the Waterloo, Cambridge area, right? And proactive maintenance and on-site repair through OTTO. But as we continue to basically wrap our arms around OTTO, we are building out capabilities through our lifecycle services organization, through our sales organization. That's where Mike and I, and if you're familiar with our territory business leads, that's where we come in too, right? So we are all getting on board because we understand how important this is to our industry, to our customers, right? And also to ourselves as a company. So we are, like I said, we are integrating OTTO into the Rockwell ecosystem and working together to basically bring a good solution, a great solution to the market. Next. Yeah, so that includes a whole bunch of different things, right? First of all, being simulation. We want to make sure that when a customer comes to Rockwell, to OTTO, and says, okay, I want my facility automated by AMRs. We go out and we actually take a look at it. We walk your facility, we look at your drawings, we understand your workflows, your shifts, your schedules. We understand what you're doing now and what you want to do in the future. And we take that in, and we have a very advanced simulation group that takes all of those inputs and puts it into basically a proposal, right? And so the next stage after we receive the PO from the customer is the integration stage. So not only are we standing up system integrators around the country, around the world to provide this solution to our customers, we also have an integration arm within OTTO. And as our SIs are being stood up, our system integration arm within OTTO is kind of taking the back seat. Our goal is to make you successful. And if you're an SI joining us today, or if you're an OEM joining us today, we can train you. We can get you stood up. And if there's enough business where you want to be a Rockwell certified system integrator or Rockwell certified OEM, talk to us. We can get you into a program where we can move you through training, and we can work with you on that as well, right? And that's the last leg of the stool too, is the training. Right now, training is largely being done in our Kitchener facility, but we have our very first training happening this week with some of our system integrators and OEMs, some of our early adopters. That's going on in Cleveland, Ohio, right? So we're expanding that training through our customer training center, through our lifecycle services, so that we can meet everyone's needs, right? That's the goal, is to get people spun up on this so they can be prepared to quote, simulate, integrate, and basically provide a solution for our mutual customers. Next. Yeah. So at this time, I want to transition this over to Mike Amendola. And Mike, I'll let you introduce yourself, but thank you so much for your time, and it's great speaking with you today.
Awesome. Thank you, Curtis. All right. So I'm Mike Amendola. I'm a mechatronics technology consultant at Rockwell, again, covering the SMC territory here, amongst others. So far, we've talked a lot about production logistics, and particularly item A that you see on your screen right there, the autonomous mobile robot element, which is great. Production logistics as a whole, we're thinking about the full factory and how we could bring that whole system together and impact your bottom line on a holistic view. AMRs, the autonomous mobile robots, is a big portion of that. But in addition to that, we also want to think about involving all the linkings of what we call islands of automation around. And so that's item B that you'll see there on the screen, the automation systems and end devices and how we can connect those islands of automation. So to complement what we have with OTTO and with the autonomous material movement, we have other means of autonomous material movement with that, within Rockwell Automation that we can look and leverage, particularly within what we call independent cart technology, or ICT, and unified robotic control, URC. So with that, we're going to talk a little bit about those different elements and how those can assist, again, within the autonomous material movement element of production logistics. Josh, if you can go to the next one. So to start off here, independent cart technology. What is it? How does it work? You can see a little video up there of some steel plates that look like they're dancing. What independent cart technology truly is, it's a rotary servo motor that we cut and we lay flat. And you still have a rotor, you still have a stator. That rotor still has magnets. But instead of that rotor rotating, because the stator is now laid flat with the coils, we're now moving side to side. So we have the ability to transverse distance as opposed to just rotate around. What that means is that there's no motor coils, or the motor coils are stationary. There's no flexing of cables. There's no wear. There's no slip ring. There's minimal maintenance, and in some cases, no moving parts at all that have wear to them. The magnets are independently driven. I can energize any coil that I want at any given time, which means I can have a handful of vehicles or magnets on a track, I can have thousands of magnets on a track, spanning kilometers of distance. So now I can take product from one side of the production facility to a completely other side of the production facility. All of this is very closed loop. It's servo-like control. I know where those vehicles are. I know where they're going, where they've been, everything that I need to know about them. If you could go to the next slide, please. So how does independent cart technology help? If you watch the video here, you'll see a handful of different examples. But the biggest elements that we want to talk about are higher throughput, unlimited flexibility, differentiated machine design, reducing your footprint, all of that. So let's talk about some of those to start with. When we talk about higher throughput, we're looking at fewer mechanical components and linkages. As I mentioned before, some cases there's no moving parts outside of the vehicles themselves that are sliding. And so in some situations, you'll have no wear parts. So because of that, we have increased uptime, decreased downtime, maintenance. From a maintenance standpoint in general, you're looking at most of these products outlasting yourselves in the industry. Many of our products have a mean time between failure of 20 years. So a lot of these products will definitely last a lot longer than you may expect them to. In addition, with the higher throughput, we also have higher speeds, higher accelerations. I can get, in some situations, over 10 Gs of acceleration, and in some situations, over 5 meters per second on speed. So I can really fly, which is going to outperform your traditional mechanical solutions, your chain conveyors, your typical belt-driven conveyance systems, and all of that. In addition, we also can reduce in-feed complexity of our systems. So traditional machines usually require some kind of product to be oriented or spaced or timed precisely on a system. We can do all of that built in to the system. And that leads into the unlimited flexibility, because when I say flexibility, again, all of these vehicles, all these carts are independently driven, which means that if I need to space product a certain size on my conveyor, on my conveyance system, because I have a package that is 12 inches long, great, I can do that. And at the push of a button, at the change of a recipe from an HMI, I can suddenly say, but now I'm running a 24-inch product on my line, and I can space those vehicles out accordingly on the fly. So I could change that from a changeover time that potentially could have taken a couple hours, a whole shift, something along those lines, to change over a product from one to another on a machine. I can now do that instantaneously. I also have constant package tracking. Because of the integrated sensors within here, I know where those vehicles are, right? So because of that, I don't need external sensors. I don't need RFIDs. I don't need external wiring to other I/O points all over the system. I can run a conveyor that will stop exactly where I want it to stop, and I know that I stopped right there because of my my feedback devices that I have built into the motors. And I don't need an external solenoid to stop it. I don't need an external product photo eye to tell me that the vehicle has arrived. So that gets me even more flexibility within this. Now, final element to talk about differentiated machine design for those OEMs and SIs and even the end users. This gets you something quite different than what you are looking with or working with the traditional machine design. I have energy savings. That's really a high element to talk about here, because instead of a large horsepower motor running all these different conveyors, and maybe I have a whole panel full of 480 volt DC or AC drives controlling all these different panels. They're all small. Maybe they're only 5 horse or half a horse or whatever it is. That's great. But with independent cart, I can have that same distance, and I'm running on low power. When I say low power, I'm talking 36 volts DC or 72 volts DC. And I'm still getting the same output. And even beyond that, I'm only energizing the coils where the vehicles are and when I need them to move. So therefore, I'm saving energy overall. I have lower power consumption. I also am simplifying my overall machine design. This is really big because instead of having hundreds of sensors and actuators and stops and all these sorts of things around my conveyance system, I don't have that anymore. I get rid of all that I/O. I get rid of all that wiring. The safety is built in. All of this is integrated together, so it simplifies how I have all that set. If you could go to the next slide, please, Josh. So what does this portfolio look like? There's really four main sides to this portfolio that we have. The first two, Magnum Mover Light and Quick Stick, those are what we would consider intelligent conveyance products. This is really what's connecting those islands of automation that I talked about earlier. It's connecting machine A to machine B. It's not on a long run like you may get with OTTO. I mean, it can be on a long run, but it won't be doing what OTTO is doing because you are on a fixed path. Unlike OTTO, which is an autonomous mobile robot. But this is going to be on a fixed path, but it still is connecting those various islands. Magnum Mover Light and Quick Stick are in its heart really the same. It's just one is the big brother of the other. Magnum Mover Light, you're looking at 10 kilograms or less. Quick Stick, you're looking at tens to thousands of kilograms of payload. They're both flexible, modular. They're like an erector set. You kind of design the track of your dreams, the layout of your dreams, and we will make those product move however you need to move it. I can have hundreds, thousands of carts on this track, and these tracks can span from small tabletops to large kilometer-sized tracks that expand the entire warehouse. It's intelligent conveyance. Now, in addition to this, we also have the iTrack and the linear solution. Those are more in your machine type of operations. Your linear solution, it's really just a linear servo motor. And so just like with a rotary servo motor where you throw a Linmot or an XLR or whatever actuator on there, I can do that integrated in. I'm still going to control it with the kinetic servo drives that you know and love. So because of that, I don't have to worry about any complexity in how I program. The iTrack is also based on the Kinetics portfolio. So while it is itself a closed loop in-machine chassis system, an intelligent positioning device for flexible conveyance, it has a backbone of Kinetics. I can program it like I would Kinetics. We have simplified programming with our libraries. We have application code manager libraries that are lifecycle managed. They're free to download. And you can program your entire system that way, but you can also program them with motion commands because it is motion at its heart. Again, iTrack is your in-machine chassis type of system. It is your case packer. It is your flow wrapper. It is replacing the complex mechanical systems that you have on a machine with this device. And it gives you that highly dynamic, high performance, high force application. So again, if I have a product in-feed screw, I have two screws that oppose each other. That way they feed the product in at a specific pitch. And, oh, hey, we're going to switch over from bottle A to bottle B. I suddenly need to take those screws off and I got to put new ones on. I don't have to do that. That is innate, built into the system. I can change the recipe with the push of a button on an HMI, and suddenly I've changed the pitch. If you will go to the next, please, Josh. So moving on from independent cart, the other element that I wanted to talk about for, again, material movement, autonomous material movement, is unified robotic control. So there's really two paths that you can move through with robotics when we talk about robotics. The first one is the Ethernet connected robots. That's probably what you're more familiar with today. That's taking partners like FANUC or taking a KUKA robot or a Yaskawa robot and plugging an Ethernet cable into that robot controller. That robot controller is controlling that arm. All of the brains of that robot is built there into that robot controller. My PLC, my Logix PLC that you're probably also using on the machine is talking back to that robot controller. Sometimes it's a nice integrated type of solution with a FANUC, let's say, and I have AOIs where I can call specific elements to that FANUC robot to control, or to that FANUC controller to control that robot. Sometimes it's simply start, stop. It's minimal control, but I have some amount of feedback or information over Ethernet, but it's all vendor specific. If I want to program that, I need to know how to program a FANUC robot, a Yaskawa robot, a KUKA robot, whatever it may be. I have to program that. I have to understand that other language. Unified robotic control simplifies that approach. I get rid of the robot controller. I am now controlling that robot arm with kinetic servo drives. I am controlling those kinetic servo drives with the same logic PLC that is controlling everything else on that system. What that gets me is a simplified approach, easier programming structure. I can now program that robot with ladder logic. I can path plan within my ladder logic, within the programming language that you know and use today. I don't need a dedicated robot controller. I don't need to be a roboticist in order to be able to understand how that robot is supposed to program. I can do that with certain vendors, with their motors, and in some situations, I can do that with Rockwell motors, VPL motors. Go to the next, please. So how is that changing the game? Everything that I just mentioned. It's empowering your workforce. It's saying, hey, you don't have to send 10 people to training on FANUC robots to be able to understand how to program a FANUC robot. You don't have to send those same 10 people to Yaskawa school, to KUKA school, to whatever robot you need. Instead, they already know ladder logic. They can already program this robot. I can launch projects faster. I mentioned application code manager libraries when I was talking with the independent cart. I could do the same thing with the unified robot control. I have lifecycle managed libraries that are free to download today that you can use. You can replicate that code. I can reuse that code, simplify my work stream, and increase my productivity. And then because I'm using robots in general, I'm improving sustainability. But even further than that, I'm doing that because I'm using kinetic servo drives. I'm using a servo drive platform that has a shared DC bus, common DC bus that I can use to have regenerative power, helping the other motors that are motoring, so I can have less power consumption overall. And in addition to all of this, I can harness the power of Emulate 3D. Emulate 3D is a great piece of software that can do a lot. But from what we're talking about here, it can accelerate my commissioning time. I can put my robot, my entire machine design, my entire robot cell into Emulate 3D, and I can virtually commission the entire robot before that robot even arrives at your facility. Before you have started cutting metal, before you have assembled the entire machine cell, I have that entire system completely virtually commissioned, including all the path planning down to the millimeter on my system with Emulate 3D. It gives me the ability to create a digital twin, and that includes my unified robot control. And with that, I'm going to hand it back over to Josh. And if you have any questions, please throw them into the Q&A. Thank you.
Yeah, thanks, Mike. I want to add to Mike's presentation there of the Emulate 3D URC and ICT that I did post some links at the beginning of the webinar to a digital engineering webinar that Mike and I did last year. And there was a video, an SMC video, the kind of demonstrating our physical demo and Emulate 3D that we have there in at the Springfield office. So if you're interested in that, go ahead, go to those links, check those out. If you have any questions, let me know. So we'll get back to business here. When production logistics becomes an extension of your control strategy, not a disconnected support function, everything changes. OEE improves because the material flow and production movement are synchronized. Throughput increases because we eliminate handoffs and bottlenecks between mobile and fixed systems. Labor ROI strengthens because engineering is simplified, maintenance complexity is reduced, and systems scale faster. The result is a flexible, intelligent, future-ready operation where material movement, automation, and control work is one. That's the power of an integrated mechatronics approach, and that's the opportunity in front of manufacturers who are ready to move beyond isolated automation and toward connected performance. By uniting material flow, automation, and control into a seamless data-driven operation, you don't just improve performance, you future-proof your manufacturing for sustained growth and competitive advantage. Coupled with unified robotic control and independent cart technology, Auto AMRs provide a flexible, intelligent foundation that makes this production logistics transformation possible. Thanks for joining. We will continue answering questions at the top of the hour here. I know we only have a couple more minutes, but in addition to that gift card, I would like to offer a complimentary evaluation for those joining today. Please follow the link upon scanning the QR code on the next slide. You can contact us through the information there provided in this slide to start that conversation. Appreciate you. Thank you.
Bye.